The gear assembly is one of 4 assembly projects provided in the problem pages. We have the gear, and we have the assembly and the pulley at the very bottom of your project sheets. Only a few illustrations are provided in each. All the information necessary for putting them together and creating the assembly are going to be through these lectures. So first of all, what you want to do is you want to go to your cadresources.com, and I've got mine in my favorites, on Creo, I should say. And you want to click on the book that you're using, and you want to download, of course, the lesson projects. And at the same time, you want to take a look over on the right-hand side of the web page, and you'll see the projects. Now, if you click on the actual illustration where it says gear assembly, it's going to open up a zip file. Got a couple of JPEGs in here, but if you're using an academic or schools or a student edition, these are the parts you want to use. They will open. If I tried to bring one of these into mine, it's going to say not possible. So you want to make sure you open up the appropriate type of part. You've got the academic version, which are these, and you got the commercial version. For my purposes, I've got to use the commercial version. That's what I have here that I'm lecturing with. And I'll go into my Gears commercial, open that up, and these are my parts. Now I'm going to close my browser, and I'm going to start a new assembly, but before I do, I should change to my correct working directory. New, and click on assembly. This is going to be the gear assembly. Okay, and you will immediately get all your datum planes, etc. So if you want, you can actually go up, depending on how you want your view to be. You can turn on your datum tags if you wish, the view tab. Now we're going to bring in these parts and drop them into the assembly. So the very first part we're going to bring in is the bracket. And drag and drop it. You'll see the cursor change. And it's going to put it where it thinks it should go. And really, we want it to be datum plane to, coordinate system to coordinate system. So right mouse button, default constraint. It'll say it's fully constrained. Check. And there's your first component. Now, let's turn the model display into an isometric for the default when we're working. Click no. Now the next part we want to bring in is the I'm going to move this up a little bit. I'm going to bring in the bushing. And you can manipulate it with the 3D dragger if you wish. It's a small part, it's not that important. You can actually turn it around like so. And most important thing here is that we're going to put in our first constraint. It's going to be an insert. So I'm going to zoom up and pick the inside here. And I think I'll rotate the model. And I'm going to pick this surface here. So there's my insert. Next I'm going to have the bearing surface. So I'm going to select here, rotate the model, and select here. Now the only thing that's not done is the third degree of freedom here. And if I go into my placement tab, I'll see that the assumptions are in there. I can turn off the assumptions, or I can just provide another set of constraints. So turn them off. You're going to see that you have some options here for rotating, but other than that, nothing else. See, the green is active. So I can rotate this. So if I want it to be always facing up or towards the flat inside the bracket, new constraint, I'm going to select here, put my cursor near where I want it to go, and hit my right mouse button until that flat highlights. Now you turn your colors off to do this if you wish. Now it's got it at an angle. Basically we want this to be just parallel. That's all. Check. Standard orientation. The next one we bring in, let's bring in the ring. And I'll move it to the other side with the dragger. And I'll rotate it. So in this one, I'm going to zoom way up. I want to use my first constraint to be like an insert, so it's really called concentric. And I want to pick this flat right here on the inside. The next constraint, I want to select this surface. And it really doesn't make any difference which side of the ring I select. You'll see what happens. You can see it goes inside, and we want to flip that so that it's completely in the groove. Now if I want another constraint, new constraint, and so for instance, let's say I'll pick the side here, and right mouse button to get to the bottom of this, or rotate it. And we're going to have our little drag handle here for the angle, and we can place it however we want. I'm going to put it at a little bit of an angle, like so. Check. Standard orientation. I do have my shading with edges on. I can see the edges better. I think I'll turn off all of my datum features. Next one, I want to put the shaft in there. Okay. And again, if you wish, you can rotate things around. It's really not that important. You do want the short side where the hole is closer to the end on this side when you're doing it. And we're going to pick on our surface here and surface here and the end, and how about the face of the bushing, like so. And we want to change that to a distance, and we'll drag it out. 2.5. Little mouse button to finish it, or check. And the next we're going to put on the crank. Drag it over. And I'm not going to bother to move. Well, I can move it if I want, but it's really not important. I like to keep it turned like this, actually. Select the two surfaces that are going to be coincident. And you can see how it's oriented here. And what I'll do is I'll select my hole on both, and we will make those coincident, like so. Now you can always go back and you can change the shaft and put a third degree of freedom in there. You can put a third constraint and establish an angle if you wish. Next one is going to be the gear. It doesn't have the gear teeth on it, just the representation of the gear. And I'm going to select the two, insert, and then drag it to the other side. Now one of the things I could do here is I could flip that, like so. And now I'm adding my next constraint. I will pick the two holes coincident, and again I have to change that like so. Now I've got this turned. Again, I could go back and I could add a constraint to turn it so that this is easier to see, pulling this one down. So the one that I did for the shaft, I could add another. Let's turn on the datum planes. I accidentally hit my middle mouse button. By the way, while we're here, let's turn on my tree filters and we'll see all the features of each one of the components. So I'll go back to that. Now notice it says here the shaft is incomplete, and we have a distance here. If you allow assumptions and we come out of that, then that little box that was here would disappear, because it was showing that it wasn't constrained. It wasn't fully constrained at that point by changing the assumptions. So these assumptions here, if you uncheck this, it's going to want another constraint. And we can add a new constraint. This one we want to have established for an angle. So if I select the datum going down the middle of the shaft, and for instance, how about the datum going down the middle of the assembly? And we see we've got an angle here now. And we can rotate it. Check. And at any time you can go in and, let's turn all this off, double click on here. It's going to give a distance, 2.5. Now we take a look at this. We have to say, all right, is everything okay? It looks all right. The problem is, let's do an analysis. See if there's any interference. And there is, and that's because the retaining ring is smaller than the groove that it's in, which it should be. Now let's try something else. Let's try diameter. This says 0.74831. Well, why? Well, if we opened up that shaft and went into the information of the model, we're going to find out that it's millimeters. So all these parts are millimeters, but the assembly is in the default of inches. So we're going to have to go and prepare our model a little bit better and go into our units and select millimeters, set. We could convert, but let's not convert. Let's just interpret and we'll see what happens. Close. Close. So what happened? Well, if you double click on the some of these dimensions, you're going to see that this says 2.5 when we inserted this, that component, and that's 2.5 millimeters. So let's just do 25 and regenerate. So it's still not far enough. Let's make it 50. Regenerate. And that looks a lot better. We also have an angle here. Let's make it 75. Regenerate. And we can turn it around. Now, if you have the student model, you're going to have to do some measuring and see whether or not everything is correct. So our diameter here, select your, in fact, zoom way in. If you have a gap here, then there's something wrong. It says 19 millimeters. And in the gear, it also says 19 millimeters. So both of them are correct. 19. So it's 19 all the way through. How about in here? It's a little bit bigger, 19.12. If yours turns out to be 17, then you have to open your model or activate the model and change the diameter. So for instance, on the shaft here, you can activate it, double click on it, and then change your dimension to whatever it's supposed to be. It might be 17, so you're going to have to make this consistent so that it fits correctly. Click on your assembly, activate, standard orientation. Make sure you, looks like we had this a little bit farther in, but make sure you finish it off. Check the dimensions, go into your standard, and then make sure you file and save it. I'm not going to do it. I'm just going to cancel it. So it's a simple project. The next one will be a little more complicated. We have 3 in a row: gear, valve, and then top-down design using the in the pulley example. This concludes the gear assembly.